Hello, I'm Sabrina Octaviani from Metallurgy and Materials Engineering. I'm going to explain about polymer materials. First, what are polymer materials and how are they different from other types of materials? First, what is polymer? Polymer is a substance that has molecular structure consisting chiefly or entirely of a large number of similar units bonded together. Many scientific organic materials use as plastic resins. Basically, polymer are formed from monomer and then we got polymer. So comparison with other materials first. The smallest entity, the metals has atoms, ceramic has short molecule, and polymers has very long molecules. For arrangement orderity, metals has large arrangement orderity, ceramic has very low, and polymer has a so-so. And for empty or free volume, metals has low, empty or free volume. Ceramic has not really small or slow. It is in the middle. Polymer has a large, empty or free volume. For density or weight, metal has large density, ceramics in the middle, and polymer has low. For electricity and transparency, metals has very low transparency, ceramic in the middle, and polymers really high. For production energy consumption, metals has really large energy consumption, ceramic in the middle, and polymer a low. For infestation, metal has high infestation, ceramics in the middle, and polymer is low. For additive modification, metals has cannot be modified, so it is very low. Ceramics in the middle and polymer very open for additive modification. Next, basic structure of polymer chain and the significance of monomers. So first is basic polymer structure. We got linear. Linear polymer is resemble spaghetti with long chain. The long chain are typically held together by the weaker van der Waals or hydrogen bonding. For branch polymer resemble linear polymer with the addition or of shortest chain hanging from the spaghetti backbone. Branch polymer used to be less dense than similar linear polymers. For crosslink polymer resemble ladders. The chain link from the other backbone, another crosslink polymer, are tied together via covalent bonding. For network polymers are a complex polymer that are heavily linked to form a complex network of three-dimension links. For copolymer, chemists is a synthesis of polymer utilizing two distinct starting monomer. Is there are several possible structure that there are random, alternating block and graft. Next is to distinguish between thermoplastic, elastomer, and thermosetting polymer. With example, first thermoplast, we got linear and branch structure for thermoplast. Thermoplast is first solid materials at room temperature but viscose liquid when heated to temperatures of only a few hundred degrees. This characteristic allows them to be easily economically shaped into the product. They can be subjected to heating and cooling cycles repeatedly without significant degradation recycle or they are recyclable. For example, PE, PVC, and PP, and PC and nylon. For thermoset, the network structure are based on the thermoset. And first, they cannot tolerate repeated heating cycle or not recyclable. When initially heated, they are softened and flow molding, but elevated temperatures also produce a chemical reaction that hardens the materials into a infusible solid. And if they reheated, the thermoset degrade and char rather than soften. For example, in thermoset is phenolics, epoxies, and certain polyesters. For elastomer, the structure is a is this polymers that exhibit extreme elastic extensibility when subjected to relative low mechanical stress, and some elastomer can be scratched by factor of 10 and yet completely recover to their original shape. Although their properties are quite different from thermoset, they are very similar molecule structure that is different from the thermoplastic. For example, natural rubber or vulcanized it's or another elastic rubbers. Next, how do the properties of polymer change with very chain length and branching? Uh, First, effect of branching on properties. Thermoplastic polymer always possess linear or branch structure or a mixture of the two. Branch increase entanglement among the molecule, which makes polymer stronger in solid state, more viscous or in the liquid state. Thermoset poses a high degree of cross-linking. Elastomer poses a low degree of cross-linking. Thermoset are hard and brittle, while elastomer are elastic and resilient. And cross-linking causes the polymer to become chemically set. The reaction cannot be reversed or not recyclable. The polymer structure is permanently changed, and if heated, it degrades or burn rather than melt. Next, how polymer classify based on their structure. First, natural structure are derived from nature without significant chemical modification. For example, include cellulose, natural rubber, silk, wool, and DNA and protein. For semi-synthetic, they are divided by two. First, petropolymer and biopolymer. So basically, biopolymer and petropolymer are the process to make the synthetic polymer. And for example, the process and the polymer is polyethylene, PP, PS, and PVC. And next is what are copolymer and how do their properties differ from homopolymer? So homopolymer consists of identification monomer and copolymer consists of different monomer, such as first homopolymer alternating random block or branch or graph. The structure are in the slide. So basically it consists of different monomer. So, what are the difference between homopolymer and copolymer? Is first, aduh, crystallinity levels. Homopolymer are higher, copolymer lower. Stiffness, homopolymer not stiff. Tensile strength, homopolymer um, not have tensile strength, impact and resistant. Creep resistant, initially good, but copolymer better in longer term. Oxidation resistance, dimensional stability, water resistant, and temperature resistant. For temperature resistant, homopolymer has higher heat distortion temperature, and copolymer endure exposure to long-term heat better. Next is okay, for packaging, the materials are polyethylene, PE, polypropylene, polyethylene terephthalate, and why it's wet because these polymers are lightweight, resistant to chemical, and have good barrier properties against moisture and gases. For clothing and textiles, the materials are polystyrene, nylon, and acrylic, and why synthetic fibers made from these polymers are strong, resistant to shrinking and scratching, and quick drying. For construction material, the materials is PS, polyphenol chloride, and PU, and Y. Polymer used in construction provide insulation or foam, piping, flooring, and roofing materials due to their durability, resistant to corrosion, and insulation properties. For medical device, the materials are silicon, polyethylene, polycarbonate, and why it has to be studied. These materials are biocompatible, can be sterilized, and have the appropriate mechanical properties for medical device like syringe, turbine, and implants. For automotive materials are polypropylene, polyurethane, polyphenol chloride. And why it is studied? Because for parts such as a bumpers, dashboard, and fuel tanks, because they are lightweight, resistant to impact, and can be easily molded into complex shape. For electronic, the materials is polycarbonate, polyimide, and ABS. And why? These polymer are used for housing, keyboard, and insulation due to their electrical insulation properties, durability. And then for sport and leisure, the materials are polyethylene, EV, and polycarbonate. And why it is studied? Because it is durable, flexible, and lightweight. Polymer are used for sport equipment like helm, goggles, and protective padding, and leisure items, because they can withstand withstand impact, provide cushioning, and are resistant to water and UV light. And environmental and energy application materials such as silicon and fluoropolymers. And why? Polymer are also crucial in environmental and energy sector, being used in solar panel, wind turbine blades, and membrane for water purification due to their durability, resistant to extreme temperature, and chemical stability. Why is molecular weight important in understanding polymer properties? First, for degree of polymerization, the mean value of n is called the degree of polymerization. The molecular weight MW of polymer is the sum of the molecular weight of the monomer in the molecule. And for the molecular weight of polymer, why molecular weight is important? Because first, from degree of polymerization, as we are talking about, uh, because higher degree of polymerization can result in longer chain and heavier weight of polymer, and then they increase mechanical strength and viscosity in the fluid state, which makes processing more difficult. So the difference between number average and weight average molecular weight are the molecular average weight is calculated from the mole fraction distribution of different size molecule in a sample, and the equation are in the slide. For the weight average molecular weight, MW is calculated from the weight fraction distribution of different size molecule. So the equation is in the slide and resulted with W equal to N times M. So the concept of crystallinity in polymer is first, both amorphous and crystalline structure are possible through the tendency to crystallize is much less than for metal or non-glass ceramic. So and not all polymer can form a crystal. And for those that can, the degree of crystallinity or the proportion of crystallized material in the mass is always less than 100%. And this is the image for crystallized regions in a polymer. The A is stand for long molecule forming crystal randomly mixed with the amorphous materials, and folded, yeah, for B is folded chain lamella, the typical form of a crystallized region. And as the crystallinity is increased in a polymer, resulted with density increase, stiffness, strength, and toughness increase, and last is heat resistance increase. Last is the concept of spherulite. So for the formation and structure, spherulite grow radiately from a nucleation point and composed of tightly packed polymer chain that crystallize in a semi-order manner. The growth of spherulites occur during the cooling process of the molten polymer, where molecular chain folded into lamella, thin plate-like structure. These lamella radiate outward in all direction, creating a spherical shape. The arrangement and size of the spherulite can vary depending on the cooling rate and the presence of impurity or nucleating agents. For properties and implication, We have optical properties. Spherulite can scatter light, which makes the polymer appear translucent or opaque. And for mechanical property, the strength and stiffness and brittleness of a polymer can be influenced by the size and distribution of spherulites. Generally, a finer spherulite structure can lead to better mechanical properties. For thermal properties, the thermal behavior, including the melting temperature and crystallization, can be affected with spherulite. That's all for me. Thank you so much for your attention, and I'm sorry if there is a wrong spelling or a wrong explanation. Have a nice day.